So far in this series, we have learned about LLMs, RAG, AI agents, MCP, and function calling. But now, suppose your manager gives you a task. Integrate AI into our Java application. Where do you even start? Where does ChatGPT fit? Do we install ChatGPT inside Spring Boot? Does Spring Boot contain the AI? Does AI contain Spring Boot? Today we will answer all these questions. As Java developers, we are already familiar with traditional Java app architecture. A user sends a request, the controller receives it, service layer contains business logic, the repository fetches data, the database returns the result. Nothing new here. Now imagine the business wants an AI chatbot. Where should we put it? Inside the controller? Inside the service or database? The answer is service layer. The LLM is usually called from the service layer. Why? Because calling an LLM is simply another business operation, just like calling another REST API. Let's understand with one example. Suppose you are working for a bank. The customer uploads a bank statement, then asks, "Can you explain this in simple English?" How would this work? The user clicks submit. The browser sends an HTTP request. Exactly like any Spring Boot application, the controller receives the request. Notice something important. The controller knows nothing about AI. Its only job is receiving request. The controller forwards the request to the service, exactly as we already do in our Spring Boot application. Now something new happens. The service prepares a prompt. Instead of SQL, instead of repository, we are preparing instructions for the LLM. The service combines user request, business data, instructions into one prompt. This prompt is sent using Spring AI. Spring AI simply becomes a Java client. Think of it like REST template. Instead of calling your weather API, it calls OpenAI. This surprises many developers. There is no magic. Spring Boot simply makes an HTTPS request, exactly like calling Payment API, Weather API, or Google Maps API. Only now the API belongs to OpenAI. The LLM reads the prompt, predicts the next word, generates an answer, and returns JSON. The response comes back as JSON. Spring AI converts it into Java objects, just like Jackson converts REST responses. Finally, the response travels back through the service through the controller to the browser, exactly like every Spring Boot application. So far, we have discussed each component separately. Now, let's put everything together. Imagine you are working for a bank. The bank has a web application built using Spring Boot. A customer uploads a PDF bank statement and clicks the explain button. Let's follow the request from beginning to end. The journey starts with the user. User enters explain my bank statement in a simple English. At this point, nothing AI related has happened yet. Now step 2 is controller. The browser sends an HTTP request. Our Spring Boot controller receives it exactly like every REST API you have written. Notice that the controller doesn't know anything about AI. Its only responsibility is receiving requests and forwarding them. Step 3 is service. The controller calls the statement service. This is where the business logic lives. The service prepares the prompt. For example, it creates something like explain the following bank statement to a customer using simple English. Then it appends the transaction details. The prompt is simply a string, nothing magical, exactly like building a SQL query or an email body. Step 4 is Spring AI. Now the service hands this prompt to Spring AI. Many developers think Spring AI contains the AI. It doesn't. Spring AI is simply a Java library. Think of it like REST template or web client. Its job is to send a HTTP request to OpenAI. Step 5 is OpenAI. Spring AI sends the request over HTTPS. The request contains the model name, the prompt, your API key, exactly like calling any REST API. Step 6 is LLM. OpenAI forwards the prompt to the selected language model. Now the LLM starts working. It reads the prompt, processes the context, predicts the next token repeatedly, generates a complete explanation of the bank statement. Step 7 is response. the generated answer is returned as JSON. For example, here content is you received your salary on June 1 or July 1. Again, this is just JSON, nothing different from any other REST service. Step 8 is Spring AI. Spring AI receives that JSON. Instead of you manually parsing it, Spring AI converts it into Java objects, just like Jackson converts JSON into DTOs. Step 9 is service. The response goes back to service. At this stage, your business logic can still run. For example, save the AI response to database or log the request, remove sensitive information. The LLM doesn't control your application. Your application is still in charge. Step 10 is controller. Finally, the service returns the response to the controller. The controller sends it back to the browser. The user sees your salary was credited on July 1, your biggest expense this month was rent. The entire request is now complete. This architecture should look very familiar because almost nothing has changed. As Java developers, we are still using controllers, services, HTTP, JSON. The only new component is the LLM. If you already know Spring Boot, you have already covered 80% here. AI doesn't replace your application architecture. It simply becomes another external service that your application can call, just like a payment gateway, a weather API, or Google Maps. The difference is that instead of returning fixed data, the AI generates intelligent responses based on the prompt. Interview question: how is an LLM integrated into a Java application? A good interview answer is: an LLM is typically integrated through an API using libraries like Spring AI. The service layer prepares prompt, sends them to the model over HTTPS, receives the generated response, and returns it to the client. The overall application architecture remains the same as a traditional Spring Boot application. Thank you for watching.